Thanks for coming to my talk. I want to talk to you about Blazor WebAssembly and how to monitor it using OpenTelemetry and Real User Monitoring. My name is Harry Kimpel. I work for New Relic as in developer relations. I have pretty much always been a software developer. Custom software development has been a key topic for me my entire life. Since 7 years now, I work for New Relic in the monitoring, or the new term is called observability space. And this is really what I'm passionate about. As you can tell from my accent, I'm not American. I'm basically from Germany. I live in the southern part of Germany, in Bavaria, close to the border of Austria. The environment is pretty similar to what I've seen here in Estes Park. It's quite nice over here. I'm really enjoying the time. But this is what it looks like over in my area. So I won't talk about WebAssembly in detail. We have seen a couple talks already, from Brian and the previous one. So I'm not going into details about this. There's a lot of things you can learn more about in the Bytecode Alliance and stuff like that about WebAssembly. But what I want to talk to you about today is kind of like an environment called Blazor WebAssembly. This is a .NET environment from Microsoft. Don't blame me on that. Don't judge me. I've been in the developer ecosystem from the Microsoft perspective quite a lot of years. So this is close to my development background. But I think they do some really nice things, especially when it comes to rendering. They have some really interesting rendering modes. You can use some static rendering on the back end and ship the data over to your WebAssembly. You can do some server-side rendering and configure your application to use server-side rendering and then ship the components to your client-side. Client-side rendering is also possible, where the components will be rendered on the client side, and the server then only updates the components. And the last one is kind of like an auto mode, which is quite interesting, because what happens is that initially when the application starts, it is rendered on the server side, and then automatically switches to the client side rendering automatically. So it's a nice approach. I encourage you to check it out. And so this is what I'm wanting to talk to you about today, Blazor WebAssembly using .NET. The interesting thing is it uses .NET on the back end and on the front end, which you'll see in a moment. Another aspect that I want to share with you today is kind of like OpenTelemetry. Who has heard of OpenTelemetry before? Okay, quite a few. Just for the rest of the audience, OpenTelemetry is a CNCF project that incorporates all the telemetry data from your applications, including traces, metrics, and logs. It came actually from a merger from two different other projects that were initially created: Open Tracing, which was focusing on purely tracing, and Open Census, which was focusing on metrics. And OpenTelemetry really combines all the things together in a nice way. It focuses, like I said, on metrics, traces, and logs, and have all the things together. This is a vendor-agnostic project. So the idea is that you implement and instrument your application once, and then you can decide what you want to do with the telemetry that you collect. You can send it to some open source projects like Jaeger to view the tracing information, or you can send it to an observability backend like New Relic. But what's important for me is, this talk is about OpenTelemetry, and I'm from New Relic, but you can apply this to any other observability tool out there. So really, what I wanted to mention here. I think this will be the future of telemetry. We do have some proprietary agents as well for application performance monitoring, but I'm pretty much sure that these will go away anytime soon. So OpenTelemetry is here to stay. Basically, if you look at kind of like the CNCF projects, this is the second most active projects when it comes to commits behind Kubernetes, which is probably expected. So OpenTelemetry, a lot of large enterprises contribute to OpenTelemetry, things like Google, Microsoft, all the hyperscalers. I had a discussion with people from DBOS yesterday. They also implemented OpenTelemetry. So this is really something, the more broader support we have in other services, where we can collect all this data and trace information to other systems, this is really where OpenTelemetry shines. It is an open standard at the end of the day. All right, and so this is also what I want to focus on today. We have .NET Blazor application using OpenTelemetry. The sample that I brought with me today is a really simple example. It has a .NET Blazor backend and a WebAssembly front end. There are some components that purely run in the WebAssembly part, and there's components where the WebAssembly talks to the backend and receives some authentication information and things like that. So this is the setup, really simple example. I'll share the link to the repository as well at the end. I encourage you to check that out. So first, we'll focus on how to actually instrument and get some data from the backend. What do we need to do? Like I said, this is purely focusing on .NET, but OpenTelemetry basically supports all major languages out there. This is a link that I put up there, OpenTelemetry.io docs languages. I encourage you to check that out because that constantly changes. I'm impressed in how frequently this gets updated. There's for .NET, all the telemetry data is in a stable mode already. For other languages, it looks a little different, like for Rust. It's in beta and alpha stage, but this will change over time quite soon. And pretty much all of the things will be stable at some point, I guess. So from the backend application, if you're familiar with .NET, you'll use a package manager called NuGet. You will install a couple packages into your application, depending upon how deeply you want to integrate OpenTelemetry into your application. And in general, there's two different modes that I will also share in this section. There's an auto instrumentation mode, where you basically just need to add these packages to your application, and then at runtime, OpenTelemetry, these packages will automatically identify information from your application. This is based on some convention. Typically in the .NET world, it uses activities to capture things like tracing, the standard logging libraries, and so on to capture logs. But basically, if you just use these libraries and use the auto instrumentation mode, you will also find there's some auto instrumentation library here that I'm using. There's not much really that you need to do inside of the application. So changing your own source code is not necessary if you use auto instrumentation. How does it look like? This is Visual Studio Code. And what I did here is I exported all the traces, metrics, and logs. I started up the application, and I'm just outputting the information into the console, which is nice. I can look at some trace information and things like that. This is a sample trace that I've highlighted here. You can see the trace ID, the span ID, some information about how long it took to execute that specific method in my function. But looking at that data in a console is not the most efficient way to basically gather that information and get some analysis of the data. So in general, what you want to do is you want to export the data into some backend system, into some OpenTelemetry backend system. So in this case, OpenTelemetry supports also some collector. So typically you would send the data to an OpenTelemetry collector where you can do some processing, some batch processing. You can do some, you can decide what data you want to keep. Maybe you want to avoid sending the debug logs to an observability backend for storage purposes and so on. And then the OpenTelemetry collector also has some exporter capabilities that you can then use. In this case, I'm using the OpenTelemetry exporter OTLP endpoint. And this is the Relic specific endpoint for OTLP, OpenTelemetry Line Protocol data. I can just configure this endpoint along with some header information. You will see, if you use a New Relic, you will have a license key. And this is typically what you use to ingest some data into New Relic. And you can see the OTLP headers environment variable will have the API key and the license key. So pretty simple. Again, I don't need to change something. This is the run script that I'm using to actually spin up the application. You can see the .NET command at the bottom. So this is what I use to spin up the application. And then what happens is, as soon as you log into your OpenTelemetry backend, you can then identify what's happening. You can analyze your data. What we typically provide in the Relic, we have some kind of overview, some summary information. These are curated experiences that we provide to get to the root cause of issues quickly. So we have some information on response time, the throughput, the error rate of the application. So we basically, once we receive that information, we do some pretty heavy processing of that data to automatically calculate metrics and so on based on that information. You can look at all the traces that I'm capturing here. So this is the distributed tracing view for my backend application. You can see all the different traces, always dependent upon the time frame that I'm looking at. On the top right-hand section, you can specify what time window am I looking at. And then you can see that scatter chart on all the different traces information. How long did the trace execution take to execute? Do I see any errors in the traces and so on? So nice way to visualize that information. And if you then click into one of the traces, you will see what we also provide out of the box is kind of like a so-called entity map, where you can visually see how this interaction works, what components are involved in this execution. And at the bottom, I highlighted this in the next section here. You can see, what was the trace execution? How did the trace execute? In this case, you already see the front-end component, which we'll cover in a second. And this is the back-end trace. You can see, in this case, this took 4.6 seconds to execute, which is nice. I see, a nice view of all the things that are happening. If I have more than these services, I will then, of course, also see all the different breakdown into other services as well. What's nice about this is also, I also do a talk on, Kafka, where you can, have a producer and a consumer. Also supported is OpenTelemetry in this use case, where you can then also see I have a consumer, a producer sending in some data to Kafka, and then some consumer receiving that information. Also, this would be part of such a trace information. All right. This brings me to the next topic. Like I said earlier, this is using auto instrumentation. So I'm basically seeing, this is using a GET request to the /roles endpoint of the backend service. But I don't have any further details into what is actually happening, right? And this is what brings me to the next section. In this case, I already applied some manual instrumentation. So basically something that I have to add something to my source code in order to get more details. I also have this a little bit more highlighted. In this case, you can see, again, I have a request to the get roles endpoint. But now if I see some in-process spans, I can look at more details of what is happening inside of that endpoint. So you can see in total, this took like 2.4 seconds on the back end, and how this breaks down all the way to some heavy lifting sleep job that I entered, just to visualize some information. How do you achieve this? Oh, and one thing also, if I'm using manual instrumentation, I can also add some additional data to these spans. And this is what you can see here on the right-hand side. I added some custom attributes. In this case, just the wait time that I'm using in that span. You can use any type of data. For example, if you have a retail application and you have like a process or a method that adds something to the cart, you can add the product ID or the product category ID. This is important for you to maybe analyze what is happening. Why are maybe certain traces failing? And you can then drill down deeper into these issues. And this is for technical analysis of your information, but some of our customers also use that for some business analysis. What are the most used product IDs that people put into the cart? Do we see any failures in the cart when we do some checkout that are only related to some certain products and so on? So this is some nice information that you can then visualize. Excuse me. So how did I achieve that? It's basically, and this is now brings me into the source code. This is the C# code behind the scenes in the /roles endpoint. This is just a snippet of that, and you can see I'm adding an activity into that code that just tells me that, hey, everything that is within that section should contribute to that roles heavy lifting sleep trace span that we have seen earlier in the view. And again, this here is then how I can add some tags and some custom attributes to the span itself. All right. This then brings me to the front-end component of the actual WebAssembly portion of the Blazor application. Since this is .NET, it is the same process. I'm adding some NuGet packages to my application. In this case, some OpenTelemetry packages that I'm using. And then, if I run the application, where do you think we can see the output of that if we use the console exporter? Any idea? This is, a web application that runs in the browser. So, of course, I can see that in the developer tools, right? So in this case, I'm outputting this information into the console again. And as you can see, this is the front end, a screenshot of the front end application. And you can see a trace of the front end exported into the console of the developer tools. Again, probably not that useful because, somehow I want to analyze that data and see what's happening. But again, I can use that for traces, metrics, and logs again and output the information to my console. But there's a challenge with that, and this brings me to some limitations of Blazor or WebAssembly in general, because once I configure then the OpenTelemetry endpoint, like to send the data not to the output to the console, but send it to, for example, our Relic backend, this brings me to this message: operations not supported on this platform, because I cannot easily send data from my WebAssembly application and send that out to the wire to my OTLP endpoint because of security constraints and stuff like that. Typically, what you would use is either a gRPC request or an HTTP protobuf request to your OpenTelemetry endpoint. But in this case, it's simply not possible, right? I assume this is work in progress. I don't have a solution for this yet today, but I assume this will evolve over time. And maybe the component model that we heard earlier today as well, maybe that comes up with some way of exporting that information in a secure and standard fashion. But as of today, this is unfortunately not possible. So this brings me to the aspect of the real user monitoring. In OpenTelemetry, there's also a component that covers the browser aspect, the real user monitoring. This is kind of like observing what is happening on the client side. If you have a web application, you can observe all your web requests. You can see whether a page has been viewed by a user, what browser has been used, what location, and so on. There's a lot of data that you can use. OpenTelemetry also has some initial support for real user monitoring. But as you can see, this is early stages. It is only supported for Node.js and TypeScript as of today. Again, this will evolve, and there will be some updates to this, also from an OpenTelemetry perspective on the real user monitoring. In this case, what I would do if I had a TypeScript application or a Node.js application, I could use an npm install and install that NuGet, that npm package for my Node.js application, which will then do the similar things on the front end as well. But since this is not yet supported also on .NET, what I did here is I used the real user monitoring from the Relic. We have a pretty easy way to get started. You can, if you log into your account, you can create a new browser. At the Relic, we call real user monitoring the Relic browser. So you can create a JavaScript snippet that you then inject into your web application or into your WebAssembly, which is what I did here. And once you've done that, the data will also be sent to the Relic backend, and you can see some interesting information about the front end itself. In the typical web application, these are the Google Lighthouse metrics, like largest contentful paint, interaction to next paint, and so on. So these are some standard ways on how to observe your front-end application. I can also see some page view load time and how this breaks down into certain subcomponents. Again, also on the front end, I can then look at the distributed tracing aspect to see if I have certain aspects where a front end calls a back end, which then does some other things, I can also visualize this information. I could even look into all of the AJAX requests. This could be requests that hit my back-end application, but maybe I have some other requests that I'm hitting, probably not in a WebAssembly, but in other aspects this would also be possible. And then finally what I wanted to show here is kind of like, again, this is the web application that is running as WebAssembly in the front end. This counter piece that is part of the sample application purely runs in WebAssembly. There's no connection to the backend whatsoever. And what I did here is and this is kind of like just showing the page source to show that there is no like anything happening in the browser itself. This is purely WebAssembly. And what I'm showing you here is kind of like on how this is the so-called Razor page of this Blazor application. You can see it is a mix of like HTML, JavaScript, and then the backend portion. You can see that add code statement here, which is an indicator that there's running something in C#. This is the pure C# code down there. And what I'm doing here is I'm invoking Blazor has support for invoking also JavaScript from the C# code into JavaScript, which is a nice way for me to also this is, if I click on the button, the counter will be increased, right? This is the backend code for that. And what I'm doing here is kind of like I'm adding a New Relic page action. This is a browser API that we support to actually add some custom actions on top of the web application. And of course, if I'm doing that, I can also then visualize that information. Each of the clicks on the button, I can then, for example, come up with some kind of distribution. Why is this important? Because there's typically probably a lot of things that you want to observe in your application. Maybe it's click on actions, or maybe if someone drills down on a drop-down list and things like that. And maybe if you want to observe this kind of information, then this is a nice way to achieve that. In the Relic, we also have kind of like a standard out-of-the-box dashboard for WebAssembly that you can use that highlights some of the WebAssembly-related information. And with that, that brings me to the last slide. I have a link to the slides here. If you scan the QR code, there's also some links on some of the references for Blazor WebAssembly if you want to learn more about that, OpenTelemetry, the Relic, and also the link to the sample repo that I used for this specific talk. Thank you very much.